All right, boys and girls, happy Monday. Welcome back to the drive-thru. Shout out to spring. Hope everybody got outside and did something enjoyable over the weekend. All right, so this is 11-2. We're continuing on in our probability and statistics chapter. Okay? What is probability? Well, it is the likelihood that something will happen. So maybe I think it was Thomas Jefferson said the only two things that are guaranteed in life are death and taxes. Okay, I don't know who said that, but that means the likelihood that they will happen is what's the highest that a probability can be? 1. The answer is 1. There is no it depends. The highest likelihood is 100%. It cannot be more than 100%. So when your coach asks you to give 100%, respectfully say, Coach, no thanks, because I will be dead. If you have given 100%, you will have 0% left, which means you are now dead. So don't give 100%, but also do your best. There's a difference. Okay? What's the least likely that something can happen? 0. That's right. So all of these answers will be between 0 and 1. Now, that means you can write them as fractions, you can write them as decimals, or you can write them as percents. I personally don't care, as long as it makes sense to you. Okay? So, that's what probability is. It's the likelihood that something will happen. What is it used for? It's used for decision-making sciences. Okay? What does that mean? Well, if I ask you to play a game for me and we decide to put money on that game, so we make a bet, you have to decide whether the bet is in your favor, my favor, or actually a fair game. So if I said, I'll bet you $5 that when you pull this card out of a deck, it's not a heart, that game would be in your favor. That means you win if it's a diamond, a spade, or a club. I win if it's a heart. You should play that game. Even if you lose, it would have been the right risk. In fact, you should play that game 1,000 times, because then you won't lose. You will win about $750, give or take. Okay? So, obviously we're not going to be all gamblers, hopefully not. Gambling is something that's okay to do if you have the money and you enjoy it, as long as you can control what you're doing. But what people do in businesses every day is they make these kind of decisions. What's the likelihood that my lawnmower is going to break down? Well, there's an answer to that. And if the lawnmower breaks down, what happens to my grass cutting business? Well, I'm going to have some angry people until I can get their grass cut, particularly this time of the year. So what do I need to do? Well, I might need to invest in like a insurance plan. So when my mower breaks, I have money set aside to rent another mower, or to get my mower fixed, or to hire another company to cut my grass while my mowers get fixed. These are the things that good businesses do. They use math to make decisions in advance based on the likelihood of outcomes. And that's why it's important. Because in today's world, as you know from the news, people are collecting data whether you want them to or not, and they're literally using that data to make decisions on how they can tailor stuff to making money. A lot of that is involved around advertising right now, but there's lots of different ways it's used. So all of you will probably need this at some point. Many of you are just naturally good at it, so you don't really know the math, but you're like, oh, this doesn't seem fair. I'm not going to do it. Or, ooh, this seems like a good opportunity. And that's good. The math can only confirm or deny whether or not you're doing it right. So I'm just going to take you through about half of this worksheet for 11-2. This is called experimental probability. So that means we are going to use the experiment that we had to predict what a future outcome's likelihood is. So a basketball player took 24 shots and he made 13. What is the experimental probability that she will make the next shot that she attempts? Well, this is the answer. Okay, because using the facts that we have, we assume that she will be equally likely moving forward, which is not a great assumption. You have to make some assumptions to do probability. And so if you didn't like writing it as that, you could just put that in your calculator and do 13 divided by 24. And so you could write that answer as 0.5416 repeating, or you could call it 54.16%. All of these are the correct answer. You can have it written any of those ways. Okay? Just make sure your answer is between 0 and 1. All right, so we're going to skip these. But I did want to take this time to show you guys how you can use your graphing calculator to create random numbers, and how you could use those random numbers to kind of settle bets between you and friends. Okay, so I pulled up my graphing calculator here. Hopefully you guys can see this window. And if you go to math, and then you go over here to probability, which is kind of where we're living in our calculator during this chapter, you can see random integer, random norm, random binary. So if you just go down to this random integer one to 5, you could say a couple things. I want a random integer between 0, where's my comma? Oops, and 1. So that means I'm going to pick between 0 and 1. If you hit enter, it gives you a 1. It gives you a 1. It gives you a 0. It gives you a 1. Think of this like tossing a coin. 0's heads, 1 tails. Okay, well let's say we wanted to pick, let's see, I'm only taking one person to the Reds game. I have one extra ticket, and I'm going to pick between the 4 apartment roommates over there, between Stas, Nick, Ephraim, and Dusty. So let's go to the random number, the random integer, and I'm going to pick between 1 and 5. So 1 is Nick, 2 is Dusty, 3 is Ephraim, and 4 is Stas. Well, this could be a way I'm going to do it. Ready? I'm going to hit it, and looks like Dusty's going. So this is a way, look, this is a random integer between 1 and 5. 5, 2, 4, 5, 2, 2, etc. Okay? So, just wanted to show you how to do that. All right, there are a group of 5 cards numbered 1 through 5. You choose one card at random. Find the probability that it is a 2. Well, you have a 1, a 2, a 3, a 4, and a 5. So there are 5 cards. Your probability that you pick a 2 is 1/5, or 20%, or 0.2. So they're all the same. Okay? Your probability that it is even, well, there's 2 even out of 5 cards. So that's 40%, or 0.4. A bucket contains 15 blue pens, 35 black pens, and 40 red pens. You pick one at random. What's the probability that you get a black pen? Well, how many are there total? Let's see. 15 plus 35 plus 40. That's 50 plus 40. That's 90. So the probability of picking a black pen would be 35 out of 90. Well, that's the same thing as 7/18, or 0.3 8 repeating, or 38.8 repeating percent. You can write all of them, but you don't have to, just however you want to write it. What's the probability that you get a blue or a red? Well, if there's 35 blacks, then that means there are 55 blues and reds. Okay, so that could be 11/18, which is 0.61 repeating, or 61.1 repeating percent. Okay? 5 people each flip a coin one time. What is the theoretical probability? Okay, so the probability of the first person tossing a head is 1/2. The probability of the second person tossing a head is 1/2. Third person is 1/2. Fourth person is 1/2. Fifth person is 1/2. This is an AND problem. And so if you remember from the last video or from the counting principle from earlier in your mathematical careers, AND in math means multiply. 1 to 2, 4, 8, 16. So it's 1 out of 32. And I like writing that as a percent. It gives me a better idea of what that actually is. So it's 0.03125, or about 3.12%. So that's where things get weird. If I asked you, if I told you this, I'll pay you $10 if you can flip a coin 5 times in a row, but you got to pay $1 every time you want to try the game. Most people would play, and you would lose a lot of money, because it's just very not likely to happen. If in order for that to happen, you would need it to be a 10% likelihood, and it's not. It's a 3% likelihood. Okay? So not a fair game. What's the probability that we have exactly 2 tails? Exactly 2 tails. Well, let's see. I'm going to add a separate video for that one. That one's tough. And I just want this video to focus on kind of general probability questions. So I'll come back and add one to the spreadsheet later on that one. Okay, 22. The spinner shown at the right has 4 equal-sized sections. Suppose that you spin the spinner twice. So, what is the sample space? What does that mean? What's all the results of spinning the spinner twice? Well, you could spin 1 twice, 1 and then 2, 1 and then 3, 1 and then 4. You could spin 2 and then 1, 2 and then 2, 2 and then 3, 2 and then 4. You could spin 3 and then 1, 3 and then 2, 3 and then 3, 3 and then 4. Or you could spin 4, 1, 4, 2, 4, 3, and 4, 4. So what is the sample space? It's that. Or maybe they're asking how large is the sample space? There are 16 different outcomes. Notice that 16 different outcomes is there are 4 different outcomes on the first one, and 4 different outcomes on the second one, and that's 16 from the previous question. And is multiply. Oh, nope, how many outcomes are there? 16. So B would be 16. What is the theoretical probability of getting a sum of 4? Oh, we just got to look. That's 4. Look, there's going to be a pattern here. That's 4. That's 4. This one can't be 4 because the 1 is 4. So in C, the theoretical probability is 3/16. And we're getting towards the end here. That is the end. I'll come back and add a video for number 19 a little bit later. Hope everyone has a great day. Boom!